All right, we are looking at the last example in section 5.3, and this is the one that I asked you to do for class participation points. The only thing I asked you to do for that was to come up with your objective function and the inequalities that you need to restrict your information to. And then after that, I will look at the graph where it should be shaded and find the optimal solution. So it says the officers of a high school senior class are planning to rent buses and vans. So that's the two different types of things we're renting for a class trip. Then they tell us a lot of information about how much students and chaperones can be in each bus and how much they cost to rent. If you follow all the way through all the numbers down to the bottom here, it says how many vehicles of each type should we rent in order to minimize transportation cost. So I know right away that we are going to be dealing with an objective function that's going to deal with minimizing cost. So it's going to be minimize, and we're going to have a C for cost. So we're going to have to figure out what that function is in a minute. We know that our variables are going to be the buses and the vans, how many of each, because it says how many vehicles. So I'm going to make my little table down here. And we're going to have number of buses that they're going to use and number of vans. And then we're going to have totals for our rows that we'll put underneath here. So X will be the number of buses, Y will be the number of vans. And then let's go back to the number part. So it says each bus can transport 62 students, requires 6 chaperones, and costs 1,300 to rent. So the cost, the 1,300 to rent, that's going to be part of our objective function. So 1,300 X. Each van can transport 8 students, requires 1 chaperone, and costs 110 to rent. So because we're trying to minimize costs, that's going to be part of that function, so that 110. We have 576 students in the senior class that are eligible on the trip, and we want to accommodate at least 576 students. So I believe just because each bus is broken down by students and chaperones, we're going to need a student equation or inequality and a chaperone one. And what we know is that they want to have on that trip at least 576 students. That means that many or more. So my student inequality is going to be greater than or equal to 576. Since there's only 66 parents that volunteered to serve, they can only use at most 66 chaperones. So that's not the same as at least. At least means this much or more. At most means this much or less. So that's going to be less than or equal to 66. Now we can go back and look at the individual things. So the bus can transport 64 students. So that would be 64x, and it would do 6 chaperones. So 6x for that. The vans can do 8 students, so 8 per van, so that's 8y, and 1 chaperone per van. So now we can come up here and say our objective function is subject to the following inequalities. 64x plus 8y needs to be greater than or equal to 576. And 6x plus y needs to be less than or equal to 66. And we have the two facts. Remember that x has to be greater than or equal to 0 and y has to be greater than or equal to 0. We can't have a negative amount of buses or a negative amount of vans. So that was what I needed from you for the class participation. So that's the correct objective function and what we're doing with it, which is minimizing. And then this is the restrictions that they have to follow. So now we're going to look at how to actually solve this problem. So if we look at the first inequality, so I'm going to we're going to try to figure out which color that's matched to. So I'm going to do it in black for right now. So that's 64x plus 8y greater than or equal to 576. So I'm going to subtract over the 64x. Trying to put this into y equals mx plus b because I'm trying to figure out if it's the blue or red line on the graph that we were already given. Divide everything by 8. That's going to be negative 8x, and 576 divided by 8 is 72. So if you look at our two lines here, I'm gonna kind of zoom out for a minute. We see that we don't really see where the pink one crosses perfectly. It's right up here, or red, I should say. But we do see that the blue one, so notice this is counting by, let's see, 5, 10, 15, 20. It's counting by 5. So this is 25, 30, 35, 40. So I'm just counting up 45, 50, 55, 60, 65, 70. And it looks like we crossed just a little bit above that. So the red line looks like it's this one. That's, remember, going to help us knowing how to shade. So we think this one is the red line. Make sure it actually switches to red. Hang on just a second. My ink pad didn't want to switch. There we go. So I'm supposed to be shading above that line. So all the way this way forever. Okay, so I'm just making a mark on that. All right, and then for our second line, so let's say we're going to do this one in purple. We have the 6x plus y less than or equal to 66. We know it's the blue line, so I guess I should do it in blue. But just for the solving part, that's going to be a negative 6x plus 66. Don't have to divide by anything because it's already y. That makes sense because this looks like it crosses just right at about 65, but it's a little higher, so 66. Now on this one, though, we're supposed to be shading less than because we only have a certain number of chaperones. So we're shading below the blue line. So you notice until the intersection point, which we're going to have to find in just a second, until that point, which it looks like it's roughly here where they intersect. So we're going to make that a black point. That's just guesstimating by what it looks like on the picture to me. So for this point right here, notice that nothing is shaded here because the red one's going above and the blue one's going below. So they're not going to intersect. But then as we get further down, now the blue is on top. And so notice we're shading kind of this tiny little slither that's in between the red and the blue. So it's going to go down. And remember, we can't go past the x-axis because we have that greater than or equal to. So I'm going to get a yellow pen just because it's hard to highlight this little spot. So just from our intersection point down, which is really thin, we are shading this tiny, narrow little triangle all the way to the x-axis. And that goes all the way up to our intersection point. Okay, so that's our feasible region. Now we need to find what that intersection point is. So remember, we set our two inequalities that crossed, which was our blue line and our red line. We set those equal to each other when they're solved for y equals mx plus b. And we'll be able to find our intersection. So this is the intersection of red equal to, this was the blue line. Okay, so negative 8x plus 72 equals negative 6x plus 66. Add the 8x over, that'll be 2x. Subtract the 66 over, that's going to be 6. Divide by 2, we get x equals 3. So we know that this point has the x coordinate of 3. If we plug that back into either one, so say you want to plug it into the negative 6x one, we can get our y. So that would be negative 18 plus 66. That is going to be 48. So this is the corner point 348. These two are just our x-axis points for the red and blue lines. If we look at the original equations before we actually solved them over, or inequalities, I like to think of the boundary line, just that part. We're looking at these and we just want to know where they cross the x-axis without their inequalities in there. You remember you just put in 0 for y. So if we divide this by 64, we see that that is going to be, I believe, that's going to be 9. Yep. And if we divide 6 over, we're going to get x equals 11. So this is the point 9 comma 0, and this is the point 11 comma 0. Okay, so we have all of our feasible region points. So now we do our corner point table. We write down our cost function, which was 1,300x. Remember, because that cost a lot to rent the big bus. plus 110y. It didn't cost as much to rent that van. And we have 3 corner points to check. Now I'll leave it to you to verify when you plug these in, but I got 9,180 for the 348. I got 11,700 for the 90 point, and I got 14,300 for the 11 0. So that means my optimal solution is that we would have a min cost of $9,180 if we rent 3 buses and 48 vans, which is a lot of vans, but that is the optimal solution. Okay, hopefully that helps.